nothing simpler, no simpler way to store to something that persists than using a file. Okay. So here we have again, we're taking here and we're saying SONET file, and we're opening this. Oh, what is Mac doing here? No idea. SONET file. Well, let's make that a little bit bigger. There we go. We're opening this file, sonet.29.txt, and we say SONET file.readLines, and what do we see? We see a listing of lines, right? Now, I have taken the liberty. Let's see if I have that file. Control D, yes. ls. Let's go here. Automate online materials, ls. Okay, there is no SONET file in the official materials. That's okay. There's a file here, and essentially when he calls read lines on it, the difference between read lines and read is going to give you one block of text with everything in that file. Read lines is going to split that text on a new line, right? So when you have 4 line breaks in that file, SONET file.readLines will say when in disgrace with fortune in men's eyes, new line, and then we have another string here, right? And then we have another string here. And I don't know why those aren't in quotes. There's actually an error in this book here. Make sure all, hold on a second. I want to make sure there's an error in that book. There's definitely an error in this book. Does anyone know why that's in there? Am I right to say that? There's no open quote. That's an error, right? What is he doing there? Let's take this, and I'm going to actually show you his code.
There's a quote in men's.
But where's the first quote here? In when? Right. And this should even be escaped.
If that's a web page rendering, the quote may have been swallowed due to formatting rules, depending upon how he set up that display.
Definitely, yeah. Yeah, I mean, it definitely could be a rendering problem, but it's a bug in the website or it's a bug in the text, one of the two. That's not correct. And
the same problem with the last 2 lines too.
Yeah, so what we're going to do here is we're going to create a directory in his called fixed. And by the way, here's extra points for anyone. This is an open Creative Commons book. Here's your, if you're starting and you're aspiring to become a computer programmer or you want to write docs, go find out where his book is hosted on GitHub, fork it, and fix it for him. I think his website is also open, you know? And it's just that would be a decent little thing you could help him out with. Okay, so what I have this directory called fixed, and I'm going to create this thing called sonet.txt, and I'm going to paste inside of it all of that stuff, which is what he's looking at, right? And we're going to write it. Let me delete that last line. Now I have inside of Sonnet, we can see all the text right there. I just put it out on the console using the command cat. And we're going to go Python 3, and I'm going to go my file equals open sonnet.txt is reading. Now if I look at my file, I see that weird cryptic IO file thing. But if I go myfile.readLines, it should be S, yes, read lines. We can see here that I get an array back. And this time, let me see if I can. Oy, why did I do that? Myfile.seek. Don't worry about that one. Just pretend like you never saw it. And I'm going to. There we go. OK, recovery from a live coding blunder. We see here now we've called myfile.readLines, and we see that we have in the first line is up at the top, and you'll see the trailing new line. It keeps it there, right, for processing. We can see the second line here. We can see the third line and the fourth line. They're all there. We've taken a block of text and we've split it by lines. And I'll tell you why that's useful. It's useful because every time you see text, right, and you're parsing it as a computer programmer, one of two things are going to enter into your mind. This is all a block, or each line is significant. Usually when it comes to actual prose, the block is totally fine, right, because the enters don't make a difference. But if you're reading something like code or a report or a receipt or anything like that, the new lines definitely make a difference, right? You look at a receipt from someone and you have item item, item. Every line is a new item. That's why. You can say for each item in myfile.readLines, right? So I could do something like this. We're going to go back. Ignore that. I'm not explaining it. We're going to say for each item in myfile, read lines. Do. There we go. This is an item, when in disgrace with, so now you've seen that I'm taking each line and I'm doing something special with it. And we could do that just as if they were in lines on a receipt. Okay. So we do here, we open the file, and now we have learned how to open files. We can read to them, and we can also read the lines from them. And we have this other method here, which is going to be writing to a file. How do we write to a file? Well, we saw when we read from the file, the second argument was R, which means read. The second argument could also be W, which means write. And if we want to write to a file, we open that. We get the file object the same way using open. We just provide to it the write flag, and then we say baconfile.write, and we can give it text. And what it's going to do is take this argument here to write and put it out to that file and return to you the amount of characters or bytes that it wrote. Right? So if I say baconfile.close, right, that file is now on the disk and it has those files in it. I'm not going to show you this because you take my word for it. It's very simple at this point. Now here's something else. We have baconfile open, and this time we're giving it an A. Well, what does an A do? Append. So here's my question. If I write to a file, let's say that I write to this file here twice. Baconfile write, I open this and I run this piece of code and this piece of code twice. What does baconfile have? It has a once. Not hello world, just hello world. Right? If you run that piece of code twice, you're going to get it once. Because what you're doing is when you open the file the second time for writing, it's going to essentially destroy the old file. Overwrite, exactly. Right? It's going to open up that file. You're going to lose everything in it. It's going to write all new contents to it. Right? So this is the difference. Append is different. If I call this piece of code here twice, I'm going to have bacon is not a vegetable, bacon is not a vegetable, because it's going to be appending it. And by the way, you will see this everywhere in computer science, in computer programming. Let me give you another case in point. Okay, I want to show you this, right? If I do this, and I'm in this thing, and I say echo foo, and I'm going to put this out to bar, what is that going to do? Anyone know? It's going to create a file called bar with the content foo. That's exactly right. Right? So if I do this, you're going to see it. Now, if I do it twice, what happens? Bar has one foo in it. But how many of you have seen this? Now if I do it, and I say cat bar, you're going to see two foos in it. It's because under the hood, it's all doing the same thing. Right? I'm just saying you'll see this. You'll see this if you're a systems admin. You'll see it if you're a computer programmer. You have two methods of writing to a file. One of them overwrites the file. The other one appends to the file. Right? OK. Just to bring it all home. Baconfile.close, baconfile.open, bacon, bacon read, bacon, baconfile.close. That's very simple. Print out content. The point here is that Mac is OK. The point here is that when I close the file, I don't lose the contents I've read. I lose the ability to read future contents without reopening it, but I don't lose anything I've read. Right? OK. Saving variables with the shelf module. Dun, dun, dun. OK. Show that only has to show that cats. Yes. And in fact, we did this last time too. This is always fun. There's a module in Python called shelve. And I think there's even another one. Pickle also does this, right?
Yes, pickle does that.
So what's the difference between shelve and pickle? Anyone want to take a guess at that one? I don't know the answer to it. What's up? You may know it. I don't know. Okay, this is a very basic thing here. There's this thing that we can do is we can import this module called shelf, right? And what we can do is when I have this shelf file, I can say shelf.open my data, cats equals this array, shelf.file cats equals cats, shelf.file close, right? And if I run these commands, and let's go ahead and do that. Okay. This is the downside to learning to use OS X on the fly. Boom. Boom. Python test.py. So we created this file, and it's essentially going to open this thing, my data, right? You'll see a file here called mydata.db. You can see here that what it is stored in it are the very same things from the array, Zophi, Poka, and Simon. So what it's doing is it's giving you an interface to store a Python data structure. When you shelf something, you take in a data structure, and you allow Python to write the whole thing out to the file and then read it all back in. Let me tell you why that's important. I'm going to play it into a different way. We've talked about reading whole files, and we've talked about reading lines. But how do you read and write data structures? How do you read and write an array? How do you read and write a dictionary? You can read and write those types of things using shelf, right? So you can import the module shelf, Python 3, import shelf, well, no, import shelve, help shelve, and what you get here is manage shelves of pickled objects. There you go. It is the same thing as pickling. It uses pickle. You have a shelf of pickled things. That's the cute mnemonic, okay? When I started this thing, I said, what is the difference between this and pickling? Python calls pickling taking an object, right, and making it a series of something you can write and read, right? Python has something called shelf, which apparently takes these pickled things and writes them to files. Okay, so then there you go. And there's nothing too special about that. Why is this cool? This is cool because it allows you to take complex things. Like let's say you had a dictionary. Inside of it, there's a dictionary, right? We've already seen these things in practice. Watch this. If I say this, A equals foo bar, right? We can see A. That's very simple. There's one key, foo, and there's one bar, bar, right? Key value, foo bar. I can say A, foo, close it, and I get bar. But I could also do something like this. B equals, and then I could say foo, and then I could say hello. Now I have an object with an object in it, right? There's a dictionary and a dictionary inside of it. To access world in that case, I would do this. B, the first key, and then I would do the second key. And I'm only showing this again because we've already seen it. I'm not going to go too far into it, right? This was way earlier on. I can get world out. Now I have a dictionary with the dictionary inside of it. Pickle takes care of all of that crap, right? So if you want to take something like this that's slightly more complex, you can write this thing out to a file and then read it back later. No more complexity to you. Open a file, shelve your stuff, your data structure. It takes care of everything. Okay. Does anyone have any questions on that? Did anyone do this beforehand? They have so much confidence in me lecturing in front of them that no one has to do anything. They just come and osmosis kicks in. And everyone leaves smart. I love it. Shelf file, shelf.open. We give it my data. We say the type of shelf file, right? Type is going to give us that thing. If we would have given type the my file from the file object we had earlier, we would have got that text.io wrapper thing. So there you go. Shelf.db.file name, right? And we can say here shelf file cats, and what do we get back out? We get back out this stuff. This is the opposite of it, right? So let's go back to the thing that we had, and what we're going to do is copy this and just show you the other side. So look here. When we did okay. We created this file just now. We imported shelf. We said shelf file equals shelf.open. We said cats are these 3 cats. Then we stored the cats into the cats key, and we closed it. Now what we're going to do is we're going to do the opposite of that. We're going to take the inverse of that operation. We're going to say, we're not going to say any of that because it just crapped out on me. 1 second. Shelf file, Command C. Okay. Where did it go? There it went. Okay. Command V. There we go. Oh, import shelf. And now we have that thing. And if we say shelf file cats, we have our cats. So you see what we did? We stored into cats key an array with 3 cats. That was a shelf file. Then we closed it. We started it again. This time we said shelf file open my data. Notice we didn't define cats anywhere. This cats is not in this program at all. We gave it the file name my data, right? And we told it we wanted the cats thing back out. My data is on the disk. When we called shelf the first time, we actually wrote a file, and I showed you this. We wrote a file, and that file is right here, mydata.db. We're reading back from that, and we're actually finding our array inside of it. So if I come down here, this is exactly what's happening. We're opening my data, and we say we want the cats array. OK. Moving on. Sharing variables with pprint.p format. So if we look at the stuff that we're doing with Python, right, it's not always pretty when we print something out, right? And I'll show you what we mean by that. If we take a look at import pprint cats. Yeah, let's see this here. What this is doing is, there we go. When we take something with Python and we say A 1, 2, 3, right? We have the option here to print A. Well, no, I need to assign it first. A equals 1, 2, 3. We have the option to say A, and we get this back. This is pretty printing for you. If I say print A, right, we get it back like that too. There's some cases, though, where that becomes more complex. And rather than going into them, I'm going to show you what we're doing here. We're just taking this. I don't actually know any of those cases off my head, but that's what we're doing. Cats equals that. And if I say cats, I can see it like this. Now there's a module called pprint, and then you can go pprint .p format cats. Right, and what it's going to do is return all of this stuff here as a string. Okay, and the reason why it's going to do that is I can take this string and write it to a file. And later on, you can read that same code back, you can run it, and get that same data structure. So that's actually what's happening. If you want to print it, it's going to send this thing here to the output of your screen. Right? If you want to capture the output, you can use pprint.p format. So now I can actually say pprint.p format string equals pprint.p format. And now when I print it out, I can see that string. Whereas before, when I say print cats, I have no method of capturing that, right? If I say here string 2 equals print cats, I should have nothing. Nothing. So here's the deal. The deal is this. When you're printing something out, it goes directly to the terminal, to the output source, right? If you want to save that and put it out to a file instead, you can use pprint.p format. Okay? And then we write to it, cats equals the output, and we close it. All right. When we import cats, right, we can import that as a variable. Now notice up here what we're doing. We say cats equals, right? I'm going to come back to the code that we wrote, and I want to show you what's happening here. We have this string equals cats. Now if I look at this, I can see the very same thing. What does this look like to you? Cats equals. What does that look like? Anyone want to give it a shot?
Variable declaration.
Looks like a variable declaration. That's right. It looks like totally valid Python code, right? That looks like totally valid Python code. So we have a variable cats. We have an array. We have this syntax here to create the dictionary. That's totally valid Python code. And what happens is, if we take that totally valid Python code and we put it in our own module, we can use it later. So that's what they're showing you now. They're showing you the very seeds of creating your own module, right? So he's creating a module that he can actually use at a later point of time. He's creating that module, though, not by writing the code, but by generating the module himself. Right? And then all you do is you say import cats, and you can look in your variables right there. This is the one that we declared, cats. Right? It's under, notice the syntax. Be very cautious about the syntax. We import the module name, mycats. There's a file called mycats.py. It's not py. It's not pm. It's pyc if it's compiled. It's regular py. It's just py. It's mycats.py, and you can say mycats.cats and get the actual names of the variables inside of that module. That's what's happening. Okay, there you go. So the file, the only catch here is that file that you create has to be .py, and then Python can just simply import it. Okay. So generating random quiz files. This is the project here. And here's what I will not be doing again, because it was such a horrendous mess last time. Even though I did paste the code from the last time we live coded shit, I pasted that in the Discord, right? And that was that time where we were supposed to pivot the table. And I could not wrap my head around doing this in baby talk, which is what essentially was learned at that point. And yeah, so I have now found the source code for this type of stuff, and we're just going to explain that because he did it better. Create 35 different quizzes, creates 50 multiple choice questions for each quiz in random order, provides the random answer and 3 random wrong answers for each question in random order, writes the quizzes to 35 text files, writes the answer key to 35 text files. That's what we're doing. We're creating a quiz generation mechanism. You give it fake answers, you give it real answers, you give it questions, you get test banks, and you get answer keys. Got it? That's what we're doing. Okay. That's the Mario theme. Okay. Store the quiz data in a dictionary, right? Random quiz generator.py. The way this book is structured, all of this code is available when he starts it like this online. And that's what we're going to be looking at. Import random. We already went through random before. What does random do? Gives you random numbers or random list elements. Remember that too? Right? So we have here capitals, and we're giving it a dictionary. You can see Alabama, Montgomery, Alaska, Juneau. These are all capitals, and these are all the states. States are keys, capitals are values. And then what we say here is generate 35 quiz files. 4 quiz in range 35, right? So range here is going to be an iterator. It's going to return 35 different things, right? And every time we loop through it, we're going to set a quiz number to one of those things. So range is a sequence. Quiz number is actually the thing inside of the sequence. Now here's the deal. For those of you that remember, because we've done this multiple different times, range is generating a special thing, right? If I want to get all of those things back, don't even have to finish the question. Nailed it. That's right, list. You would wrap range in list. It's a very common Python idiom, okay? Create the quiz file and shuffle the questions in order. Now it's time to start filling in those to-dos, okay? So here's what we do. For quiz in range 35. Now we're starting to fill it out. We say quiz file open, and we say capitals quiz S text. What is that S? That's exactly right. Okay, you're off for the next 30 minutes. You got this down pat. We're gonna have to wake some other people up. Okay, capital quiz S. S is a placeholder for a string. What we provide to it on the other side is the value, right? So this and this together is a Python syntax for saying I want a string that says capitals quiz and then quiz number plus 1. I want to show you how that works here really quick, just to refresh your mind, because we're all new. If I say this here, I say hello, S, and then I say S, and then I say world, right? I could even do like that and be more. I get hello world. That's all that's happening there. We have a format string on the left-hand side, and we have the variable to fill it in on the right-hand side, right? So that's what this does. And then the only other thing that we have here is the write flag, right? So we're creating a file name. That's what we're doing here. And we're opening it up to write. Then we say answer key file. Because remember, we have to create an answer key for every test, equals capitals quiz answers and the same number .txt. And we open it up to write. Then what we do is we say quiz file.write, and we're throwing into it this name. And we're also 2 lines entered, date, 2 lines, period, right? So we're essentially starting it off with a place where students can write out their headers, right? So think of it like this. They give it to you. There's nothing in there. That's where you fill it out as your student. My name is this. My date is this. I'm in the 3rd period. Okay. Quiz file.write. We have an empty string with 1 character, right? It's a space character, I should say. And what is this in this context? What's the word for it? If we have a string and we have a multiplication sign, what does it do?
Concatenation. Repetition.
Ah, repetition.
What he said.
Repetition, that's right. Concatenation is
When you have
plus. You concatenate with plus on strings. You repeat with the asterisk. So we're saying, give me 20 spaces. That's what this is. You could write them all out, but here he's just being explicit. Give me 20 spaces. State capital quiz form, and we're doing this again, right? This same nonsense right here, where we're saying this is a format string, and this is what goes inside. So we say 20 spaces, the state capital quiz, and then we have the form number, right? Okay. And then we put in 2 more spaces, two more new lines rather. And what we're going to do here is we say states equals list capitals dot keys. Give me an array of all of the capitals, right? The keys for the capitals. What are the keys for the capitals object? We saw it, states. That's exactly right. You look into capitals, you give it a state name, you get the capital back. So the keys are the states. So we want a list of all the states. Then we say random.shuffle. I said, what does random do? Generates a number. That's the number 1 thing that should come to your mind. What else can it do? It can shuffle a list. It does anything like that. So it's going to shuffle that list randomly. It's given back in random order, right? Okay, easy peasy. Now we're going to create the answer options, right? For each question number in range 50, right? All we're doing here is we're saying we're going to generate a list again through 1 through 50. And if you want it to be in an array, you do. Popular Python idiom is list, right? List range to get that in a list form. We say here correct answer equals capitals, and we give it the name of that state, right? Wrong answer equals list capitals dot values, right? And then we say essentially what we're doing is we're getting a right and a wrong answer, right? This capitals, we just created it, and it's in random order. And the correct answer, we're looking up, right? Then we delete the wrong answer. So we take out of the wrong answer, which is everything in scrambled up, we take one of them out. Why do we take it out?
Because you don't want the right answer and the wrong answers.
Yes, that's one good way to do it. But that's one interesting way to think about it. But here's another interesting way to think about it. If your wrong answer is always the same thing, you're going to have a hint. You want the wrong answers mixed up, right? But you don't want to keep using the same ones. So we delete from the wrong answer bank the correct answer. Wait, you were right. That what you said is dead on. We don't want the correct answer to show up in the wrong answer, so we delete from the wrong answer bank this. Okay. Then we print the wrong answers, right? We capture the wrong answers, we sample them, we want 3 of them. And we capture the answer options, which are the wrong answers and the correct answer, and we're shuffling. And we're going to see this in practice here in a second. Let's take it and let's actually look at this. Quiz. DDD. Whoa, not what I wanted. Kitty, there we go. Okay. Quiz. What's the thing? Quiz? I thought it was quiz something, no? Random quiz generator, that's what he's calling it. No. I thought he had a full copy of this thing here. I don't even see it. You know what happened? Here's what happened. I moved it. I tried to import that into the thing here, and I did. And it came down here. Capitals quiz. Yep, that's exactly what happened. It did work. Whoever was helping me out with PyCharm earlier on in the day, that actually worked. That moved the file into the PyCharm directory. Fantastic. So we have, sometimes you think something fails and it actually works. It's pleasant. So here's the actual code, right? Here's where we're generating these quiz files. We've already seen that. Here's the more complex stuff, this question number thing. Loop through all 50 states, get the right answer and wrong answer. We pull out the correct answer specifically. For the wrong answer, we take a listing of all of the answers, right? And then what I want to do is simply delete the right one, remove the right answer. Now I'm sampling. Random sample is another method we've seen. So far we've seen random shuffle to mix up the order and random sample to pull out a certain amount of numbers from it. We're random sampling the wrong answers to grab 3 of them, right? Then the answer options for that question equals the 3 wrong answers and the correct answer, right? So why are we putting the correct answers in brackets? Can anyone tell me?
So you can add a list to a list.
Boom. Because if we try to add a list and an item, we have a problem, right? You can add 2 lists together, and then it does that. It makes sense. And you can add 2 strings together, and it concatenates them. But if you want to add one thing to a list, you either have to push it, or they both have to be lists, and you can use the list concatenation plus. It's exactly right. And then what we're going to do here is we're going to shuffle the options, right? And we're going to write them out. Blank, what is the capital of blank, right? And we say, this is the question number. So the first thing is question number, what is the capital of the state, right? Then we're going to print out all of the options, and that's it. Answer key file.write. We're going to write out the answer keys, write out the quizzes, and we close both of them when we're done. And I just ran this, and I didn't actually know it worked, but I think what it did is when we thought, here's what happened. We ran this earlier in the class. You guys didn't see it. And we had a little balloon that was pivoting, right? And I thought the shit just crapped out. And what it was actually doing was generating 35 tests and answers and pulling them into the IDE. That's what was actually happening. So when I was making fun of Mac again, that one, it was actually doing something under the hood and not crashing. OK, and then here's all of our question quizzes and our capitals quizzes, right? Capital quizzes and capital answers. Let's take a look at one of them here, and we'll show you what we generated. Here's the name, date, and period, like a student would get. Here's the name of the quiz. This is form 35, so you know where to check it from. And here's all of your questions and answers, right? What is the capital of Oregon? Salem, Salt Lake City, Albany, or Oklahoma? Salem. Oregon's not all that important. I wouldn't blame you if you didn't know it. Joking. Capital answers. We can look at capital answers. There's our answer guide. Right? So that's a relatively short period of code that we have, and we did that all today, right? So now you can generate something that creates a quiz. Now all we have to do is get jobs as elementary school teachers, and that will be tremendously useful. Okay. And we still have 30 minutes. Comment and shelf setup. Let's start your code by making a skeleton script with some comments and basic setup. Look at your code like the following. Python 3, mcb.pyw. Saves and loads pieces of text to the clipboard. We've already seen this once, right? We already did something. What did we use before? Does anyone remember the name of the module? Piperclip, right? Piperclip was the name of the module we used before. And that was a module that we added on through pip. And that was our first module that we installed that didn't come with Python, right? So we said, we're going to write something that allows us to write a password manager, if you guys remember that task. And the password manager worked like this. We kept a list of all of our accounts and our passwords, and we wanted to give it the account name and then have that password copied to the clipboard. Then we could just go to the website and paste it. So you would say Piperclip, my Piperclip app, and then Chase or whatever. It would copy your banking password to the clipboard. You go right in and paste it. So now we're seeing something similar, I'm guessing. And again, here we have the same module, Piperclip, right? So this is an improvement, I'm assuming, over the thing that we just did. Right, let's take a look at this and actually read it. Project multi-clipboard. So you can write a Python program to keep track of multiple pieces of text. This multi-clipboard will be named mcb.pyw, since MCB is shorter typed than multi-clipboard. The pyw extension means that Python won't show a terminal window when it runs the program. See Appendix B for more details. This program will save each piece of clipboard text under a keyword. For example, when you run py mcb.pyw save spam, the current contents of the clipboard will be saved with the keyword spam. This text can later be loaded to the clipboard again by running multi-clipboard spam. And if the user forgets what keywords they have, they can run list to copy a list of all keywords to the clipboard. So essentially what we're doing is the same thing, except we're going to store the data in this shelf. Right? So here's what we're doing. We have this method here to save the clipboard content. We talked about sys.argv before. Does anyone remember it? Anyone remember what sys.argv is?
Man on earth.
It's the arguments that you send to Python, right? So let's come down here and let's take a look at it. There we go. If I do import sys, and then I say sys.argv, you can see nothing's there. If I come back to Python, right, and I say Python 3, hello, HLUG. I actually thought that would work. That doesn't work. Let's try this. Nope, that also doesn't work. You can't pass arguments to the REPL. That's what's happening. Annoying.
When you run the Python script, you give it arguments, right?
Right. So that's what we could do here. We could say here. OK. I'm trying to see if any of them are useful for our purposes. Skip the first line of the import source, allowing use of non-Unix forms. Let's try that, whatever. Python 3s. There we go. And now import sys and sys.argv. OK. I fold on that one. We'll look at that later. What Python does, and not the REPL, but your scripts anyway, here's how it'll work. We can take something here. Let's show you this. Test.py. And I can say import sys, sys.argv. And now what I do is I can see in that argv 3 things. Right? I have passed it here to Python 3, test.py, hello, and world. And you can see the first thing is the name of the script I'm running. The second argument is hello. And the third argument is world. Right? What we're doing here is we're looking to see out of the thing that we're running, we want to see whether or not I have 3 arguments, right? That means that I'm passing 2, and the first one is the script, right? If you come back and you look at what we did, we passed 2 arguments, hello and world, and we got a length of 3 here. So if we have a length of 3 and the first argument is save, right? We have the name of the file, save. Then what I want to do is store in the shelf the second argument, paperclip.paste, right? So what I'm going to do is if I have save and then 2 things, I'm going to store in my shelf under the second thing I sent to it, paperclip.paste. So here's how that's going to look. If I have something like this, python.thing, save foo, right? What I'm actually going to be doing here is I'm going to write into the shelf under foo the result of paste, whatever's in the clipboard. So you're essentially, you give it an argument, and it looks at whatever's in your clipboard, and it stores whatever argument you give it with that value in the clipboard, right? And then if the length of the argument equals 2, that means there's not 2 things I'm giving it. I'm just giving it one. Rather than save something, I just give it 1 thing. Then it's going to list keywords and load content. Okay, and we call MCB shelf.close. List keywords and load a keywords content, Python 3. Okay, we're adding to it now some things. If the first argument is list, rather than save, I say list, what does it do? Then what it does is it copies into the clipboard, right, the string of the list of all of the keys. So what are all of the keys for the MCB shelf? That's going to be whatever all of the crap is that we've stored in this clipboard, right? And we're going to actually take it and we're going to copy all of that stuff into the clipboard. So we have a file. That file has a bunch of things we want to store in our clipboard vault, right? And when I call it with list, it's going to copy into the clipboard all of the keys from that file, right? And if the argument is 1, right, and it's not list, then what does it do? It copies just that 1 thing. So we have 3 modes here. Let me show you how this is going to look. We have my file, or script.py, essentially, save foo. We have script.py list, and we have script.py key. That's what we're doing. We're covering those 3 cases. In the first one, we save into the vault for the key whatever's in the clipboard. In the second one, we list all of the possible keys in the vault. In the third thing, we give it a key, and it looks into the vault, finds out whatever the value is for that key, and it puts that in our clipboard. Does that make sense to everyone? This example could just be too boring, or I could just not be presenting it right. I don't know. The clipboard vault thing was not a big hit the first time we did it, and now we're making it more complex. But that's what's happening. OK, the password locker. Let's take a look at it now, and let's run it, and I'll show you how it works. Done. mcb.pyw. Because this is it, mcb. So Python mcb.pyw list. Oh, that's because I haven't installed this. pip3 install. Now you guys get to see the syntax again. When you ever see this, no module name paperclip, it means you have to install that module. And we talked about that before. Paperclip is code we don't write, we just use. So now I've installed paperclip, pip3 install paperclip, and now I'm ready to rock. I can come back up, Python 3. No? Oh, that's because that's Python 2. Python 3. There we go. So I have the ability to say list. I have the ability to say save foo. I have the ability to say foo. Now here's the thing it didn't do. It didn't copy anything. Let's try this one more time. Save foo. Yeah.
It copies it to your clipboard and you can paste it into something to see.
That's what's happening. Thank you, my friend. I'm expecting you to print it out because I am zonked. So here's what we're doing. We say save foo, and then what I'm doing is I'm pasting it, and I get the same thing. So let's do something more exciting with this thing, right? What we're going to do here is we're going to go mcb list. We see nothing, right?
Because it copies it to your clipboard. The list of keywords.
The list of the keywords is copied to the clipboard too. So if I paste that, I get the array foo, right? Let's take two things here, right? Let's do this. I'm on a site, and I see this. And I say, OK, I want to save all of this text. I can copy this. I can go over here. And we can say into mcb.list save this for later, right? Now if I say Python 3 mcb.py list, and I paste that, I see save this for later in foo. You see how what I did is I copied text from the thing. I copied this text. I came over here and I said save it as save this for later. Now when I list it, it copies that key, save this for later, and it shows it to me there. Now I can say here, Python 3 mcb.pyw, and I can say just the name, save this for later. And now what's back in my copy buffer? All of that text, right? So it gives you the ability now to essentially, we can save whatever we want. It looks in our copy buffer. It saves it to the file. We can list, but when we say list, it doesn't print it out. It just simply copies the keys into our copy buffer. And we can paste it. And when we paste it, we're going to see this name and whatever else we have. And if we actually want to get this stuff back out into our clipboard, we can just simply say what we've done here. We called it with the key name, right? Which is here, Python 3 mcb, save this for later, right? And it's going to copy that text passage back from our database, our file, and paste that into our clipboard, or make it available in our clipboard for paste. All right, that's a tongue twister. And I think that's it. Summary, practice questions. If you want to do the practice questions, do them. We'll go over them next week. If you want, if no one does them, I won't go over them, and we can just start the next chapter. For those of you that aren't aware, the next chapter is organizing files. So we're going to continue down this path, and we're going to talk about other things we can do with files that are slightly more practical, having seen the basics today. Very cool. Anyone have any questions? All right, we're done. And I'd like to give another shout out, thank you in the back, to Kenya for allowing us to borrow the adapter which made today possible when we lacked preparedness.
Thank you.
Also, thanks to Robert, who's geeked out. And I want to show everyone this, if you can't see it. This is what we're now bringing our AV equipment in. It is looking more and more like mission control every time. Also, thanks, shout out in the back for our silent warrior, who you don't ever get to see because she's always in the back. But Jessica, who handles our Facebook account and our Discord. So when things don't work and we need someone to yell at us, we have someone who will promptly do that for us because she watches all of our social media. What's up, Ed?
Let us not forget the microphone attachment device.
That's right. Yes. And thank you to Ursula for her always handy microphone attachment device.
All right, so next time we'll roll credits and everybody.
That's right. We should go over that. Everyone who made it possible. Also, we have one more person to thank, Zach, for being in the back, and you're also handling it. We have 2 copies of this that are available at all times that are on YouTube, and 1 copy that is streamed.
I wouldn't go that far. 2 copies at all times.
Well, one.
There's always something. There's always some glitch, but yeah.
Yes, there we
A
go.
lot of effort to not.
We have redundancy in this. This group has definitely grown by leaps and bounds, and I feel like we have a media team, a Facebook team, and yeah, it's actually more professional than I think any place I've ever worked. It's crazy. All right, thank you a ton for everyone that's contributed to it. Appreciate it.